Welcome everyone. We'll just give it a minute for people to join. I think we can get started. Share my screen. As always, just a little bit of housekeeping. This call is being recorded. So if you do not want to participate in this call, suggest you leave now. And as well, we have the antitrust policy notice as part of the Linux Foundation that we have to fight off. Today on the agenda, we have 3 topics. We have a little bit of an update on 1.3. So 1.3 is out 2 weeks ago, and we released 1.3. We're going to talk a little bit about the features that were added to 1.3. We're also going to talk about, I want to show the new documentation website, that we've picked up the new Hyperledger template, and then any other topics that the community wants to raise and discuss. All right, I'll go straight into presentation, and feel free to interrupt me at any point in time as I cover these topics. So yay, Hyperledger FireFly 1.3 is here, just over a year after the 1.2 release. We released a new version of FireFly. It has a lot in it. And yeah, big thanks to Nico. He's no longer participating in the project, but big thanks to him to getting this version out. So what's new in FireFly? There's been a lot of work to make the runtime a lot more modular. One of the pieces of work was to decouple the way the orchestrators within FireFly communicate with the blockchain connectors. So between the FireFly namespaces that run in FireFly core and the different plugins, Nico did a really interesting piece of work to create multiple event streams. So each namespace would have its own event stream to communicate with each blockchain connector it's connected to, instead of using the same event stream across different namespaces. So here we have more isolation across the namespaces, and this is a really good step to achieving high availability, which is an issue we've had for a while. We've called active-active. I think that we'll pick up in the future in other calls. Great shout out to the Tezos connector coming to life as part of 1.3. We have a few of the maintainers here that have contributed that Tezos connector. It's great to see. We've interacted with that community. We gave a talk in the Tezos community about FireFly, so it's great to see that integration. Andrew contributed the FireFly improvement proposal 17, where you can pin a data transfer to any smart contract function. So this extends the batch pin available feature that FireFly has been using for a long time as part of multi-party setup. It extends it to be able to use your own smart contract and pin data on any smart contract function, really, across different blockchain technologies, right? Both EVM and Fabric there. We also have made a lot of big changes to the blockchain toolkit, connected toolkit, FFTM, the FireFly Transaction Manager. Really big piece of work by Pierre to make it more performant, have a pluggable persistence layer with PostgreSQL. I'll dive a little bit deeper into that, and a lot of changes into how transaction summaries are created and stored in that tool. We've also made significant enhancements to the Kubernetes community samples that are based on Helm. Nico put together and updated those Helm charts for the release. He made it a lot simpler to be able to deploy the FireFly stack and to also deploy the dependencies that go up with that stack, such as different blockchain nodes, IPFS nodes, and the other plugins. Along that, we've also really integrated a lot better with Hyperledger Besu. We have here on the call Matt, that's both a maintainer of FireFly and a maintainer of Besu. And we've worked a lot on performance and making sure that the FireFly stack can integrate with Besu, and also enhancing the stack for problem diagnosis, for getting receipts of transactions, for getting more information on revert errors, and etc. That we can touch upon as well. I think that was one of the topics a few months ago in the community calls, and then we got to that, and there's even a document that was added by Matt on that. Any questions so far? Okay. So one of the things I looked at before this call was looking a little bit at the Linux Foundation. They create a set of insights for the project and the contributions. You can take a look. I'll leave the link here around all the different contributions. I filtered, the filter's gone, but I filtered exactly for the release date of the previous release, the 6th of February. The contributors have been growing. There's been new contributors. It talks a little bit about the insights around how active, all the PRs or the issues. I'll let you dive into that. But one of the big things is we have 64 new contributors, which is exciting. And this is across all the FireFly repos. And we have 6 new maintainers that have been, voted in during that time frame, and have been added to different repos and with different levels of access. So yeah, I'll share the slides afterwards, and you can take a look at the insights provided by the Linux Foundation. So one of the big pieces that I've mentioned is this namespace isolation. So previously we had a single event stream for each blockchain plugin. So if you had a namespace configured, for example, to talk to Besu, which you had one transaction manager, and you wanted to reuse that transaction manager in namespace 2, we're using the same event stream. In this case, it's a WebSocket that communicates between FireFly core and transaction manager and uses one subscription to listen to all the events. In this case, what we've done in 1.3 as part of this work is we create one event stream per namespace. So now we have complete isolation for that event stream. We can replay events specific to that namespace instead of sharing the same event stream across both namespaces. And as we talked about earlier, this promotes high availability. So if we wish to in the future, as we want to work towards being able to run multiple FireFly core runtimes, having that isolation in place is going to help us a lot. There is a section in the...
I could talk a little bit to this one, Enrique.
Yeah. Go ahead, Pierre.
So the work that we did, Andrew and Nico and myself, in this release, it's kind of hard to state the size of it. It was the listener moving was the big thing that changed to become independent. But really what this ended up being is now inside of a FireFly runtime, right? You've got one Go process running inside of there. Every namespace is running completely independently. There's no overlap. The config for it is read independently. The batch listener works independently. The streaming from the different connectors is completely independent. The connectors are namespace aware, so that there's no dependency when if something reloads, it might affect another. So that really is, it's been a journey. Some of this work happened in 1.2. The big piece happened in 1.3. It's a really significant step forward to the runtime, because what it means is it's now completely modular, right? There's just lots of little modules that are running, and they happen to all run in the same runtime. Another piece of work that happened in 1.3, we sort of not claimed it here because it didn't get pushed all the way through, was leadership election has been implemented in the Go code base. So we have the ability for these sort of modular namespace runtimes to be leader elected by Kubernetes is the default implementation of a leader election, but pluggable like everything in FireFly. So what this means is you can have theoretically still that you can have lots of active runtimes all doing database queries, all supporting read queries, active, and each namespace will be running its listeners only on one of those runtimes at any given point in time. But if that one goes down, it doesn't need to. That runtime doesn't have to fail over. The next one will just pick up and run. So it gives the ability. There's some impact on HA, but the really big ability it's going to give, and we expect to have this in the next release, the ability to sort of have one big server that scales across more than one VM. So you can scale beyond just the size of one VM to multiple VMs and have active running. So it's a really, really significant piece of work, even though there's still a little bit that's sort of coming out into hopefully a patch release that this will close out in.
Awesome, thanks, Peter. And yeah, if you want to look at the migration guide, it will explain that not a lot of breaking changes here. The only thing that changes the naming of those event streams has changed. But yeah, really, really great, significant work here. So next one on the list is the FireFly improvement proposal 17. This is what to be able to tie any arbitrary piece of off-chain data to any arbitrary piece of on-chain logic. So FireFly has had this for a long time, this ability to be able to perform aggregation between off-chain data and on-chain data and have ordering based on on-chain events. We've now extended that to be able to use your own custom contracts and to be able to pin data on your own custom contracts. Before we had specific FireFly contract, which was the batch pin contract, which drives all the private messaging and broadcast messaging. But now we've enabled this to be more customizable from an end user perspective to any contract. Any thoughts from the maintainers on that one?
I don't know if was Andrew on and wanted to talk about that one, otherwise I can.
I do not think Andrew's on for that one.
Okay, yeah, let me talk then a little bit more about this. This again was another big piece of work, but it is I guess it's an interesting area. So the core thing that FireFly does is be your ability to connect to any blockchain and invoke any smart contract and stream any events. That's its core like mission in life. There's a secondary thing that it has baked into it, which is a pattern for messaging and data coordination, where let's say you're building like multiple parties are all going to use FireFly, you've got an application on top of it, and you want to do workflow orchestration between those parties. You've got your identity system that you've plugged into FireFly, you've got your transport that you've plugged into FireFly for HTTP or Kafka or some end-to-end encrypted messaging. All of those things are pluggable. I can now have workflow where the order is proved by the blockchain and the messages are flowing off-chain, but they'll be processed in the order of the blockchain. So that's very powerful. And in, I think, 1.1 of FireFly, we allowed, with token connectors, to sort of have a special workflow so that you could make the blockchain transaction that was coordinated with that message be not just a pin of, but also like a timestamp, but it could be a transfer of a token. And what this piece of work did was it said, so that can be any logic on the blockchain. So I can have really powerful, interesting logic on the blockchain that isn't limited just to tokens. And I can have the processing of the data be coordinated with the processing of the event that's emitted from that smart contract. So the smart contract, the blockchain, stays in control as it always is. It's the source of truth. But as a as a party in a system that's not just got to worry about the blockchain, I'm an enterprise, I've got core system integration, I want to trigger off of this and do something, I can not take my part in the ecosystem, like decide to perform a payment or process an invoice or deliver some goods until I've not just received the blockchain, but I've also received the data that can't go on the blockchain along with it. So that's what's so powerful about this, is it's like two streams of information. It's the engines coordinating two things happening: the receipt of data and the receipt of the order and confirmation from the blockchain. So this is about putting the blockchain in charge for sophisticated transactions and still having data that can't go anywhere near the blockchain. Now, I think this is a journey that there's lots more happening in the future on sort of off-chain, on-chain, data coordination, privacy. I think we'll see a lot more on this going forwards. But this was a significant step on the journey, sort of enhancing this sort of messaging support that's baked into FireFly. I hope that was useful.
Yeah, super useful, Peter. Any questions about that? Awesome. All right. I guess this one as well, Peter, I'll give a quick overview, and then I think you're the main contributor here in terms of the persistent. But we've enhanced the persistence layer in the FireFly Transaction Manager. One of the biggest changes was just adding a more pluggable persistence layer by adding support for PostgreSQL. Before we're using LevelDB in the previous versions of this toolkit. And we've also restructured a little bit the way the transaction history, not a little bit, but substantially, the way transaction history is stored. I've linked the PR there because there's some changes to the information returned by APIs. The way the history, there's a query parameter to be able to change the history that gets returned, the new version of it, the sub statuses of transactions. So really look into that. And we've also ported a lot of this into our FireFly common layer, which underpins a lot of the Golang based services that we provide in FireFly with those capabilities for Postgres. Anything there, Pierre?
Well, did we also have a slide on the Besu FireFly integration? Because maybe I'll talk about the two in combination. Do we have a slide on?
We don't have a complete slide on Besu. I have a bullet point at the end, but if you want to cover it here.
Yeah, maybe I'll cover it here. So I think it's probably other maintainers have done the heavy lifting that are on the call. Chung's on the call and Matt Whitehead on the call. So this is part of a really significant piece of work. So FireFly is a very pluggable enterprise tool, and the blockchain connector in particular is a really pluggable framework. I think we'll talk about Tesos in a little bit more detail as an example of another ecosystem using the connector. But it's pluggable in lots of different ways. It's pluggable with the persistence layer now. It's pluggable with what we used to call the policy engine, but we call it the transaction manager endpoint. And there's like a pretty good open source implementation of that, but the intention is that there's lots of behaviors people might want to put on top of there and lots of scaling characteristics. So it's a place where this really is an open source extensible project. And a really interesting piece of work that I guess sort of taking the FireFly hat off just for a second and talking about the Kaleido hat and collaboration there. The sort of Kaleido as one member of the ecosystem, we we made a bunch of contributions into the open source that included this, but lots of other pieces around it, around problem diagnosis and other pieces, which were based on us really hammering, absolutely brutally hammering FireFly to go as fast and as reliably as it possibly could with Bessie. And I guess just to share where we're at, FireFly can go just as fast as Hyperledger Caliper, for example, when driving Hyperledger Bessie now. So this release is like a myriad of tiny tweaks all over the code bases and in the microservices that mean that, you know, if you use Hyperledger Besu and Hyperledger FireFly together, we've sort of, the community's proved that like you can get the absolute most out of Besu. And things like being able to diagnose it by seeing what's happening on the 10 steps of getting a transaction through, the transaction history bit of this. Things like having a much higher performance persistence layer for Postgres compared to LevelDB, which just couldn't cope with the types of queries that are needed. LevelDB is very high performance, but there's certain things that it does really well and certain things it doesn't do really well. Like that whole piece of work, it's sort of a hidden hundreds and hundreds of hours that have been taken up along this journey. Yeah, so I guess I'm rambling a bit, but I don't know if Matt or Chung wanted to say anything more on that sort of better together bit of work that we've done.
Yeah, thanks, Peter. Yeah, I think it's useful to kind of reflect more generally something we've seen in Hyperledger Besu workshops and financial institution workshops around Ethereum have generally been that the market is landing on Besu as the de facto EVM node for enterprises. And I think that has led to a lot of the work that you've talked about, Peter. It's encouraged us to, certainly as a Besu maintainer, I've spent a lot of time on hardening, and that brings with it some performance benefits because stability of Besu, I don't think was great 12 or 18 months ago. And as you say, a lot of the testing we've done has been combining FireFly and Besu as a really great kind of combination for EVM-based integrated networks. So yeah, I think that's the only thing I'd add right now. You'll see that there have been some PRs specifically around pulling in Besu specific behaviors into the EVM Connect layer, and I think I'd like to see more of that, where we're seeing Besu evolve for enterprise users and adding new features that you're not likely to see in Geth or Quorum. Then I'd like us to see FireFly continue to kind of make the best use of any enhancements Besu adds, so that again we can continue to improve performance between the combination of FireFly and Besu together. Yeah, I think that's all of that out for now. Chung, feel free to.
Yeah, so another thing that happened in the FireFly transaction manager is we used to have a plugin component called policy manager. That's been refactored quite a lot into something new called transaction manager. The reason we did that is based on the experiment that we've done in Kaleido, we find the boundary between the common code that manages the transactions in the engine and the handler that orchestrating all the transactions